Hello everybody, I am Maram Khatib, a postdoc at the Robotics Lab of Sapienza University of Rome. It's my pleasure today to introduce our work about task priority matrix under hard joint constraints. This work is done with my colleagues Khaled Al-Khudair and Alessandro Di Luca. For a kinematically redundant robot, the most common way to execute the desired Cartesian tasks with different assigned priorities is to use null space projections. This method is simple and ensures a strict priority. However, it requires recursion from highest to lowest priority tasks and possibly back, and suffers from joint velocities discontinuity during any change in the task priority order. Also, joint constraints couldn't be respected explicitly. The discontinuity problem can be solved using suitable scaling factors to switch between the tasks smoothly. Using the SNS method, hard inequality constraints in the joint space are satisfied. The task priority matrix method has been proposed by Fabrizio-Flacco to separate redundancy resolution from task priority handling. In this case, any change in the task priority structure requires only to modify the TBM matrix, F, which contains a compact but complete information on the different task dependencies. Note that the TBM method returns exactly the same solution obtained by the null space projections. In our recent work, we extended and implemented the TBM method at the acceleration level to eliminate any discontinuities in the joint velocity due to any change in the task priorities or dependencies. In this way, we allow also the consideration of any other additional task at the joint level to be included as null space terms. However, in both methods, joint inequality constraints have not been considered. Limits on the joint space can be strictly respected using SNS algorithm. Successively, the joints that would exceed their motion bounds are discarded and reintroduced at a saturated level in a suitable null space. The algorithm includes an optimal task scaling in case the desired task trajectory is unfeasible under the given joint bounds. In the SNS basic version, only single desired Cartesian task is considered. In this work, we propose another extension to the TBM method in order to include joint inequality constraints in the priority stack of tasks. For this, we combine the basic SNS algorithm with the original TBM method. According to the proposed algorithm, joint inequality limits are always at first priority, and then the desired Cartesian task priority is imposed through the F matrix. Here, the scale factor S is uniformly applied to all tasks, regardless of their priority. Our proposed solution can be seen as an alternative to the SNS algorithm for multiple tasks with priority. When using the latter, however, the scaling factor is applied on each task separately and by the least amount. When no joint limit is exceeded, namely W equals to identity, the solution returned by algorithm 2 is exactly as the TBM method. A comparison between the original TBM and the proposed SNS TBM algorithm is done through MATLAB simulations, using a simplified version of Robot Romeo with 21 degrees of freedoms. The robot should handle 4 Cartesian tasks according to the following priority. On the right figure, commanded joint velocities are in blue, while the red lines represent the enforced joint limits. Using the TBM method alone, joint velocities would violate their limits frequently. Using the proposed algorithm, all hard joint velocity limits are respected along the whole motion. Task errors increase when the scale factor S needs to be applied to recover feasibility. In this work, we propose a new simple and fast algorithm for task priority handling under inequality joint constraint. In the future, we will optimize the task scaling procedure and validate our results experimentally. Please share with us any comments or queries in the following Q&A session. Thank you.